Welcome to Math Contest Drills for Filipino Kids. In this presentation, let us show the solution to MTAP 2024 Elimination Round for Grade 10 students. This is part 4 of 5 parts, numbers 31 to 40. Let us look at the instruction. Give all fractions and ratios in lowest terms. All denominators should be rationalized. Express all equations of lines in the form ax plus by plus c equals 0, where a, b, and c are integers, and a is greater than 0. Figures given are not drawn to scale. Let us begin with question number 31. Find the measure of angle 1 in the circle shown if the measure of arc PQ is 94 degrees and the measure of arc RS is 120 degrees. Here is our suggested solution. Since we are given the measure of arc PQ and the measure of arc RS, let us first name the angle adjacent to angle 1 as angle 2. Hence, we can solve for the measure of angle 2 equal to 1/2 the sum of the measures of arc PQ and arc RS. Substituting the values, we have 1/2 times 94 plus 120, and this is equal to 1/2 of 214 degrees. Therefore, the measure of angle 2 is equal to 107 degrees. And since angle 1 and angle 2 form a linear pair, we have measure of angle 1 plus measure of angle 2 equals 180 degrees. And since angle 2 is 107 degrees, we have measure of angle 1 plus 107 degrees equals 180 degrees. Therefore, measure of angle 1 is equal to 180 minus 107 degrees, and that is equal to 73 degrees. Number 32. Pentagon ABCDE is inscribed in a circle. Its angles are in the ratio 8 to 8 to 7 to 7 to 6. Angles A and B are the largest, and angles C and E are equal. What is the measure in degrees of minor arc BD? Here is our suggested solution. Let x be the scale factor, then angle A and angle B are the two largest angles, therefore measure of angle A is equal to 8x. Also, measure of angle B is equal to 8x. Angle C and E are equal, hence measure of angle C is equal to 7x as well as the measure of angle E. Then the measure of angle D is equal to 6x. Since the sum of the angles in a pentagon is 540, we have measure of angle A plus measure of angle B plus measure of angle C plus measure of angle D plus measure of angle E is equal to 540 degrees. Then we have 8x plus 8x plus 7x plus 6x plus 7x is equal to 540 degrees. Adding the terms in the left-hand side, we have 36x is equal to 540 degrees. Then we have x is equal to 540 divided by 36. This is equal to 15. The minor arc BD circumscribe angle C. Then the measure of angle C is equal to 7 times 15, and this is equal to 105 degrees. Angle C subtends arc BAD of the circle. Hence, the measure of arc BAD is twice the measure of angle C, and that is equal to 210 degrees. Therefore, if the measure of arc BAD is 210 degrees, the measure of the minor arc BD is equal to 360 minus 210, that is equal to 150 degrees. Number 33. In a circle, a chord that is 24 centimeters long is 5 centimeters away from the center. Find the radius in centimeters of the circle. Here is our suggested solution. Though not drawn to scale, let us have a chord on the circle that is 24 centimeters long. And according to the problem, this is 5 centimeters away from the center. Then the perpendicular distance of the chord from the center is 5 centimeters. This 5 centimeter segment, since it is perpendicular to the chord, it divides the chord into two equal segments that is equal to 12 centimeters each. Hence, the radius of the circle will be the point from the center to an end point of this 24 centimeter chord. Then, by Pythagorean theorem, we can solve for the radius of the circle equals square root of 12 squared plus 5 squared, and this is equal to 144 plus 25. That will be square root of 169. Therefore, the radius of the circle is equal to 13 centimeters. Number 34. In the figure shown, arc QPR is a semicircle with radius equal to 6 units, and measure of angle PQR is equal to 30 degrees. What is the area of triangle PQR? Here is our suggested solution. Since arc QPR is a semicircle, then QR is the diameter of the circle. And since the radius is 6, then QR is equal to 12 units. Since angle PQR is 30 degrees and angle QPR is an angle that is inscribed in a semicircle, then angle QPR is a right angle and triangle PQR is a right triangle. Triangle PQR is also a 30, 60, 90 degree triangle. Therefore, the measure of segment PR is equal to half the measure of segment QR, and that is equal to 6 units. Also, since this is a 30, 60, 90 degree triangle, then segment PQ is equal to 6 square root of 3. The longer side of a right triangle of a 30, 60, 90 degree right triangle is square root of 3 times the side opposite 30 degrees. Hence, the area of triangle PQR is equal to 1/2 times PR, which is 6, times PQ, which is 6 square root of 3. Then this is equal to 36 square root of 3 over 2, and that is equal to 18 square root of 3 square units. Number 35. Find the length of the common internal tangent of two circles with radii of 4 cm and 12 cm, whose centers are 20 cm apart. Here is our suggested solution. Let us have two circles with radii of 4 cm and 12 cm respectively. The centers of these two circles are 20 cm apart, and we're looking for the length of the common internal tangent. Let A be the point of tangency on the smaller circle, and B be the point of tangency on the bigger circle. Then we're looking for the length of segment AB. Since the radius of the smaller circle is 4, and the radius of the bigger circle is equal to 12, we have two similar triangles in the figure. And since the centers are 20 centimeters apart, let x be the distance from the center of the smaller circle to the point of intersection of the line of centers and the common internal tangent. Hence, the distance between the center of the bigger circle and the intersection of the line of centers and the common internal tangent is 20 minus x. Since the two triangles formed are similar, we have 4 over 12 equals x over 20 minus x. Solving for x, we do cross multiplication, that is 80 minus 4x equals 12x. Then we have 80 is equal to 16x. Dividing both sides by 16, we have x is equal to 5. Now, the common internal tangent AB is the sum of the longer segments of the two triangles formed. Then we can form the equation AB is equal to the square root of 5 squared, that is the value of x, minus 4 squared plus the square root of 15 squared, that's 20 minus 5, minus 12 squared. 5 squared minus 4 squared is equal to 9, that is square root of 9. 15 squared minus 12 squared is 81, so we have the square root of 81. Square root of 9 is 3, and square root of 81 is 9. Therefore, AB, or the common internal tangent, is equal to 12. Number 36. A tangent and a secant are drawn from a point P outside a circle. The length of the tangent segment is 6 inches, and the length of the chord part of the secant is 9 inches long. How long is the secant? Here is our suggested solution. Let us draw a diagram showing the given information from the problem. Let AB be the tangent segment and BD be the secant, passes through point C on the circle. Since the tangent segment is 6 inches, then AB is equal to 6, and the chord part of the secant is 9 inches long, then CD is equal to 9. From the given figure, we can have the equation AB squared is equal to BC times BD. Substituting the values, we have 6 squared equals BC times BC plus 9. Then we have 6 squared is equal to BC squared plus 9BC. Then this is a quadratic equation. So we have BC squared plus 9BC minus 36 is equal to 0. Factoring this quadratic equation, we have BC plus 12 times BC minus 3. Equating each factor to 0, then we have BC is equal to negative 12 or BC is equal to 3. Since BC is a distance from point B to C, then we have BC is equal to 3 and BC equals negative 12 is an extraneous root. Therefore, the second BD is equal to BC plus CD, and that is equal to 3 plus 9. Final answer is 12. Number 37. The points P, Q, S, T, and U lie on the circle as shown. If measure of angle PUT equals 100 and measure of angle R equals 10, find the measure of angle U. Here is our suggested solution. From the given information, measure of angle R is equal to 10 and measure of angle PUT is equal to 100. If the measure of angle PUT is equal to 100, then the measure of arc PQT is equal to 200, since the measure of an inscribed angle is half the measure of its intercepted arc. Then if the measure of arc PQT is equal to 200, the measure of the minor arc PT is equal to 160. Now from this information, we can have the equation measure of angle R is equal to 1/2 the difference between the measure of arc PT and measure of arc QS. Substituting the values, we have 10 is equal to 1/2 times 160 minus measure of arc QS. Let us solve for the measure of arc QS. Then we have 20 is equal to 160 minus measure of arc QS. Then the measure of arc QS is equal to 160 minus 20, and that is equal to 140 degrees. Angle U is an inscribed angle that intercepts arc QS. And since arc QS is 140 degrees, then the measure of angle U is half this measure, and that is 70 degrees. Number 38. Chord CD of a circle is bisected by chord AB. CD intersects AB at E. If AC equals 5, CD equals 6, and AE equals 4, find the diameter of the circle. Here is our suggested solution. Let us draw a diagram representing the information given in the problem. From the given information, AB intersect at E, therefore CE is equal to DE. And since CD is equal to 6, CE is equal to 3, as well as DE is equal to 3. Now AC is equal to 5, and AE is equal to 4. Notice that triangle ACE has lengths 3, 4, and 5, which is a Pythagorean triple. Then we can say that triangle ACE is a right triangle with a right angle at E. Since AB bisects the chord CD and it forms a right angle, therefore AB is a diameter. Now solving for BE, we can have AE times BE is equal to CE times DE, since these are two chords of the circle intersecting at the interior of the circle. Substituting the values, we have 4 times BE equals 3 times 3. Therefore, BE is equal to 9 over 4. Since AB is the diameter of the circle, then AB is equal to AE plus BE, then that is 4 plus 9 over 4. And this is equal to 16 over 4 plus 9 over 4. Therefore, AB, the diameter, is equal to 25 over 4 units. Number 39. If a sector of a circle has perimeter 28 and an area of 49, what is the length of the arc of this sector? For our suggested solution, let us draw a diagram for this problem, and let R be equal to the radius of the circle and S the length of the arc of the sector. Since the perimeter is 28, we have 2R plus S equals 28. And the area is 49, then we have 1 half RS equals 49. Let 2R plus S equals 28 be our equation 1, and 1 half RS equals 49 be our equation 2. From equation 1, we have 2R is equal to 28 minus S, and R is equal to 28 minus S over 2. Substituting R to equation 2, we have 1 half times 28 minus S over 2 times S is equal to 49. Now, multiplying both sides of this equation by 4, we get 28 minus S times S is equal to 196. Now we have a quadratic equation. 28S minus S squared is equal to 196. To solve for S, let us rewrite this equation in standard form. So we have S squared minus 28S minus 196, or plus 196 equals 0, which is a quadratic or a perfect square trinomial. Then we have S minus 14 squared is equal to 0. Equating the factors to 0, then we have S is equal to 14, or the length of the arc of this sector is 14 units. Number 40. Evaluate 7 factorial times 4 factorial divided by 5 factorial. For our suggested solution, let us expand each factorial notation. Then we have, for 7 factorial, we have 7 times 6 times 5 factorial. And then for 4 factorial, we have 4 times 3 times 2 times 1. This is divided by 5 factorial. Then we have 5 factorial over 5 factorial equals 1. Then we have 7 times 6, that is 42, times 4 times 3 times 2 times 1, that is 24. So we have 42 times 24. This is equal to 1008. That will be all. Thank you for watching. Please subscribe for more math contest drills for Filipino kids videos.